big area in calculus is being able to solve differential equations, and there are several applications of solving differential equations out there in the real world, and I will be showing you a PowerPoint tomorrow to show you kind of some of those areas where you might encounter differential equations in your field of study. But we will just be doing the basics today. At the end of this lesson, you'll be able to use separation of variables to solve a differential equation. All right, when we're looking at differential equations, if you remember a differential equation, this would be an example if I had dy dx equals x plus 3. That's a differential equation. I actually have been using that word, I think. There was even one on the last test. A differential equation is just an equation that involves a derivative. So, and when it asks us to solve it, just like what you did on the last test, we just took the derivative, because we know if we want to get rid of the derivative, we take the integral, and that's exactly what we're going to be doing on this. We're going to do a method that's called separation of variables to do this, and when we get to the examples, I'll show why we would want to do this. We're basically going to make sure that the x's are on one side and the y's are on the other, and then we will use integration just like we're used to find a general solution of the equation. All right, so first example, you notice this is a differential equation, and it says to solve it, and it's just a differential equation because there's a derivative in it. And we know when we go to solve this that we're basically just needing to take the integral. The difference between this problem and ones that you've seen in the last chapter, notice that we have an x and a y, and that kind of throws a wrench into our plan. So we've got to do something a little bit different, and that's why we're going to do something that's called the separation of variables. Basically, we need to get all the y's on one side, and we need to get all the x's on the other side. So the way that we're going to do this is cross multiply, and I am going to put up top in capital letters, and you should as well. Whenever you see a differential equation and it has an x and a y in it, cross multiply. That's your number one step. You will notice that on the AP test, these will be problems that are worth 9 points, and you'll lose like 7 or 8 points if you do not cross multiply. So that is the number one biggie step you got to do. Okay, so I'm going to cross multiply. I always like to put the y on the left. It just makes my life a little easier because we'll be solving for y. So I'm going to have 2y dy equals the square root of x dx. Okay, now notice that I do have all of the y's on one side and all of the x's on the other side. Now I want to get rid of the derivative, and the way that I'll do that is to take the integral of both sides. Right? This left side is a very straightforward problem. I just increase my power by 1 and then put the reciprocal of the power on the outside. When I do that, I will get y squared. And then equals on the left side, I'm going to rewrite this as x to the 1/2. And then again, I'll just increase my power by 1 and do the reciprocal outside. And when I do that, I'll get 2/3 x to the 3/2. And remember, the dy's and the dx's cancel out because we're taking the integral of a derivative. And then my final step is just to put plus c because we need to add the constant. We could technically add the plus c to both sides, but we really only need to add it to the side that has the x on it. So that's the solving it. If you wanted to go one step farther, this is an acceptable solution, but if you did want to go one step farther to get rid of the square, we could square root it. So we could square root this whole side. The only problem with that, when you do square root it, you have to remember to put plus or minus in front. So either one of these is an acceptable answer. Okay, let's try another one again. The directions would be to solve this, and we have a derivative, so we know we need to take the integral. But notice I do have an x and a y, so hopefully it's screaming out in your head right now that the first thing that we need to do is to cross multiply. So let's cross multiply. Again, I like to put the y's on the left. So I'm going to have 3y squared dy equals the quantity x squared plus 2 dx. All right, all my y's are on one side, my x's are on one side. We can now take the integral of both sides. Okay, the left side, again, if I just increase my power by 1 and the reciprocal on the out front side, I'll get y cubed, and then equals. On the right side, since there's a plus sign, I can actually set this up into two separate integrals, so don't forget you're allowed to do that. So the integral of x squared would be 1/3 x cubed, plus the integral of 2 would be 2x, and then plus c. And that is a fine answer to leave like that. If you did choose to go farther, we could take the cube root of both sides and get y equals this. And there we go. That would be my answer. Alrighty, let's try another one. Notice we've got this time y prime equals x times 1 plus 2y. First thing that I'm going to do, y prime really just means dy dx. So I'm going to do that first. So again, we're trying to solve for a derivative, and to solve for a derivative, we know we need to take the integral. But again, I notice that I have an x and a y. So the second that I have an x and a y, hopefully you know exactly what I'm going to write at the top of my paper right now. We need to cross multiply. Okay, and notice if we cross multiply, I have a fraction on the left side. I do not have a fraction on the right side, but we can easily turn it into a fraction by putting a 1 under there. Okay, so y is on the left side. I'm going to have 1 dy equals, and then on the right side, I will have x times the quantity 1 plus 2y dx. All right, are the y's and the x's on the sides where they belong? Absolutely not. So I notice that I need this 1 plus 2y over on the left side. So to get it over there, since it's multiplied right now, I'm going to divide both sides by the 1 plus 2y. So I am now going to have 1 dy over 1 plus 2y, and then equals x dx. Now notice I have all the y's on one side, all the x's on one side. I am ready to take an integral. Okay, and a lot of these are going to rely on, are you good at finding the integral of a problem? So this will be nice, good extra practice. All right, I notice on this one that on the left side I have a denominator. And remember from the last chapter, if we have a denominator, we usually let that be the u. So we'll let u equal 1 plus 2y. du, the derivative of this would be 2 dy. Notice I have the dy, I'm missing the 2, so put a 2 on the inside and a 1/2 on the outside. I now have 1/2 the integral. If I look at what I have, the 2 dy is du, and this does turn into a du over u problem, and hopefully you're extremely familiar with your formulas now, that the integral of du over u is ln of u. Okay, so the left side is done. Okay, the right side, fortunately, is a lot simpler. We just use our power. The integral of x is just 1/2 x squared, and don't forget that c. All right, from here, we want to attempt to solve for y. So the first thing that I notice that I need to do is we're going to multiply every single part by 2 to get rid of that 1/2. So now I'm going to have natural log of 1 plus 2y is equal to 2 times 1/2 would just be x squared. And then 2 times c, 2 times a constant is still just going to be a constant, so I don't have to put 2c, I can still just put c. All right, here's where it gets a little bit tricky. Notice from here, I still do not have y all by itself. So I'm going to come up here, I'm going to rewrite what's there. We've got ln 1 plus 2y equals x squared plus c. Okay, from here, we learned that if we want to get rid of an ln, this is at the beginning of the last chapter, we can follow the logarithm loop. Remember, the base is e right now, so I'm going to follow the loop around. So I'm going to get e to the x squared plus c is equal to 1 plus 2y. So now notice the ln is gone. I'm going to be now solving for y. So I'm going to get the y by itself, I'll subtract 1 from both sides. So I'll get e to the x squared plus c minus 1 is equal to 2y. And then I'll divide the whole entire equation by 2. So I'm going to get y equals e to the x squared plus c minus 1 all over 2. Okay, that's basically my answer. I'm going to do one more thing to this problem, and hopefully this will make sense for you. Okay, e to the x squared plus c can actually be written as e to the x squared e to the c, because if I were to, when I have the same bases, I add the exponents. So this right here is an equivalent way of writing this problem. Okay, from here, just like I said, 2 times a constant is still just a constant. E to a constant is still just a constant. So another way of writing this problem would just be c e to the x squared. And we still have the minus 1 over 2, and it still equals y. So if you have a problem that looks like this, following through the process, we really just end up with a c being bumped out front. So it's just c e to the x squared. So if you see something like that, we can always do that. All right, I'm going to try one more problem. This problem is very similar to problem 3. So if you would like to pause the video right now and try this problem and then come back and see how you did, that would be an awesome thing to do. Otherwise, I'm just going to go ahead and work through it. Okay, first thing that I am going to do, instead of y prime, let's write dy dx, and then equals 5y. Alrighty, we have dy dx. To get rid of a derivative, we take the integral. However, I do know notice there's an x and a y. So first step, write it up at the top of my paper, we need to cross multiply. All right, don't have a fraction on the right side. Let's turn it into one big fraction on the left. Okay, cross multiply. Y is on the left, so x plus 3 dy equals 5y dx. All right. The y's and the x's are not in the right spot. So first of all, I'm going to divide both sides by x plus 3. Okay, so I'm going to get just dy equals 5y dx over x plus 3. Now I notice I don't want the y there, so now I'm just going to divide both sides by y. Notice the 5 is fine where it is. It doesn't involve the y or not, so we're just going to get rid of the y. So notice now I have dy over y is equal to 5 over x plus 3 dx, because those y's cancel. Okay, now that I've got all the variables on the right side, now we can take the integral. Okay, on the left side, hopefully you notice this really is the exact same thing as du over u, dy over y, dx over x. If I see something like that, my answer will just be the natural log of y. Okay, on the right side, I have a denominator, and since it's a little bit more complicated, we do need to do a u substitution on this one, so I'll get x plus 3. So du equals just 1 dx. Notice I just really want a 1 there. I don't want the 5 there, so I don't want the 5 there. I'm just going to move it outside so it's not in my way. All right, so this actually now is equal to 5. The 1 dx is just du, and then I just have u on the bottom. So nicely, this is another natural log, so I'm going to have the natural log of y is equal to 5 natural log of u, which would be x plus 3 plus c, and we always put the plus c on the side with the x. Just to clarify up here, if I lost you at all, since I wanted a 1 there instead of a 5, I could have done 1/5 on the inside to cancel it out, which means I would do that reciprocal on the outside, which would be 5. So either way, hopefully that made sense for you. Okay, now on this problem, just like we did, I'm going to rewrite this up here again so I have a little bit more room. We do not want the ln in the problem, so we can follow the logarithm loop. Our base is e, and switch it around here. So I'm going to have e to the 5 ln x plus 3 plus c is equal to y. So notice pretty much I'm all set. Now hopefully you remember from the previous example, when I have the plus 3 sitting up here, it really just becomes c e to the 5 ln x plus 3, and that is equal to y. So now we have a general solution. So now hopefully you're familiar with separating the variables to solve a differential equation.